Hi there. So we're going to move forward now into another area that you saw first in Algebra 1 and you worked with, but in Algebra 1 it was pretty much a whole quarter of your background was on solving equations. So today you're going to start seeing the solving equations. We're not going to do the easy ones like x plus 3 equals 5, so what's x? We're going to move into the multi-step ones and we're going to build from there. So please make sure that you take notes, especially on the sets, because the set of steps that you're going to see require for us all that we need to be able to solve not only just regular equations for x, but also solve for any variable, even if there are other letters mixed in. So here we go. So we're going to start off first with our first definition. Remember when we talked at the beginning of the year about our definitions, we said an equation has an equal sign. It creates for us two sides, one that has a left-hand side and one that has a right-hand side. On either side you could have numerical expressions or variable expressions, but that equal sign creates for us two separate sides and also gives us the set of directions that we need to solve the following. And remember that when you solve, your mission is to get always the variable down to a positive 1, x or y or z, equaling whatever number it is. Okay? And you need to hold on to that. I also want to remind you, and you started to see this with our coefficients before, in our adding and subtracting polynomials, that a coefficient is that number that's attached to the variable through multiplication. So just be careful of that, because we're going to see coefficients as we add or subtract variable terms together, and you're going to have to remember what we learned about adding and subtracting polynomials. And lastly, I want to just remind you that a solution for this, if you get x equals 2, that is a solution only if when you substitute that x value back in the original example, you get something that makes the left-hand side equal the right-hand side. So it's only when you substitute your answer into the original question and your left-hand side equals your right-hand side. All right, so here are the steps that I need you to write down, and if you need to pause the variable, I need you to do that to get these. These are critical steps that are going to carry for several days for us, and I'm going to go through this verbally each and every time. So as you look at these steps, the first checklist that you have to ask, always following order of operations, is that if you see parentheses, you got to focus there. Now typically for our solving equations, that means you're going to distribute. And we did that when we were adding and subtracting polynomials, because what we did is we used multiplication to distribute all the way through that problem. And you need to please make sure that you remember that. The next checklist, if you see fractions, most of you don't like fractions. So now with an equal sign, we can get rid of them by multiplying every term by the bottom number. And make sure that you remember that that denominator is what's causing it to look like a fraction. So I want to get rid of it so that I don't have the visual look of any fractions, but I just can't make it go away. I've got to do this by following proper procedures. Once you get rid of any fractions, you're going to look on your left-hand side and just like our adding and subtracting of polynomials, say, are there any similar terms on that side? Then you're going to look on your right-hand side and say, are there any other similar terms on the right-hand side? So on one side, we're saying, can I combine anything together through addition or subtraction moves? Then I highly encourage you guys to box your variable terms, and notice that I put plural here because sometimes you'll have a variable just on one side, but other times you're going to have a variable on both sides, and that changes our procedure of how we're going to have to maneuver these things to solve for that variable that we see. If you do have variables on both sides of the equal sign, the left-hand side and the right-hand side, you need to move those variables together first through addition or subtraction moves. Remember that that equal sign is like a balance bar. What action you take onto one side, you must always do onto the other side. And if you move your variables to the left-hand side, then your constants always have to go on the opposite side. So after you move your variables onto one side and you move your constants onto the other side, You really should have a variable term on one side, a constant term on the other, and then the last thing that you will always do then is to divide by the coefficient of the variable so that you solve for the x or the y, whatever that variable is. So let's look at these steps in actions. So the first example that we're going to look at is 4/5 x plus 8 equals 20. Now again, as I handle this problem, the first thing that I do is I always put a line through my equal sign. For me, it's a visual break between my left-hand side and my right-hand side. So then I'm going to go through my checklist of steps. Do I see any parentheses? And I don't, so that means I don't have any distribution that I have to take into consideration. Second checklist, do I see any fractions? And in fact, I do. We have a 4/5 x, and even though that's 0.8, I'm not going to change it to a decimal. I'm going to keep it as a fraction. But I want to remind you that, again, it's a fraction because of that divide by 5. So in order for me to get rid of the look of the fraction, what I'm going to do is multiply every single term by that denominator number. So the 4/5 x gets multiplied by 5, the 8 gets multiplied by 5, and so does the 20. Every single term on both sides gets multiplied by that denominator. Now what happens to the first term, that 4/5 x, is ultimately the reason that I multiplied all things by 5 is so that the denominator would go away. They cancel each other out. Ultimately, I'm saying I have a 5 divided by 5, which is a 1, and that's why it goes away. Notice that it leaves me here, though, with my numerator term, and that will always happen, so please hold on to that. And then 8 times 5 gives me that plus 40. 20 times 5 is 100. So at this point in time, all fractions are taken care of. I look on the left-hand side and say, can I combine similar terms? And the answer here is no. I have an x term and I have a constant term, different terms. So I box my variable term, and I have to move that positive 40 away from the box so that my variable is all by itself on one side. And remember, we do so by doing the opposite operation. So if it's a plus 40, I'm going to subtract 40, and whatever action you take to one side, you need to take to the other side. So the 40s on the left cancel out, and I'm left with just 4x. 100 take away 40 is 60. So then from there, our final step, because I have variable term on one side, numerical term on the other, is to break apart that coefficient from the x through division, and I divide both sides by 4, and 60 divided by 4 for us is 15. Now again, as you look at this particular problem, if you're fairly confident with your work, you can stop there. Otherwise, what you can do is check your answer. And it's a great way for you, if you have time, to know that your answer works. So if you go back in the problem, pluck out x, put in what x is, which is 15, we're checking, does my left-hand side and my right-hand side have balance? Are they equal? And what we're going to do here is we're going to make, because it's joined through multiplication, we're going to make that 15 a fraction. We're going to multiply straight across the top. And we get 60 over that 5, and I'll just carry the plus 8 equals 20, and 60 divided by 5 is 12. And for sure, the answer we got works. Now, as you're doing these particular problems, again, I don't require you to check, but it's a way for you to verify one way or the other. Please make sure that you're showing me the process very much like what you're seeing here. I will require proof that you get the answers that you need. All right, our second example, again, I'm going to put a line through the equal sign, and I'm going to go through our checklist. Notice again, there are no parentheses, so I don't have to do any distribution. Second check, get rid of fractions. There are none, so I don't have to do any distribution. If I look on the left-hand side of my problem, I have a 8y and a negative 16. They're different terms. If I look on my right-hand side of my problem, I have a 13y and a 9, different terms. So what I'm going to do now is I'm going to box both of my variable terms on either side. And then the critical thing that I like to do is I always like to move my smaller variable to the larger variable. And the reason for that is that my number will then always be positive, and that will help us when we move away from equal signs to less thans or greater than. So because 8y is smaller than 13y, And because 8y is positive, I'm going to bring it across the equal sign by doing the opposite of a positive 8y. I'm going to subtract it across. And again, notice what action I did to one side, I did to the other. So the 8y's cancel off on the left-hand side, and I'm left with just negative 16. And then if I take 13y's and I subtract 8y's, I only have 5y's left over. And notice that that positive 9 just carries all the way down. I'm going to rebox my variable term, and now I need to move my constant term all to the left-hand side. So that positive 9, the opposite is a subtract 9, and that's what I do to both sides. Cancels on the right-hand side, so I have 5y alone. And here my signs are the same, so I'm going to add the numbers and keep the sign. So now that I have my constant term on one side, variable term on the other, I break my coefficient away from my y by dividing, and I end up with negative 5 to be y, which I would carry down below, but I ran just a little bit short on room. And again, check your answer and see if we get balance with the left hand on the right hand side.